So we have overall 13 chapters, 13 чаптеров, главата. И all of the basics are pretty well explained in other books as well. But what I like from Resnick is induction. They explain induction really well because it's in advanced topics, in advanced books like Purcell or Griffith or even Prut. They don't explain much details. They just go into the applications. So, but in Resnick they explained it really well. So, and electromagnetic waves, it's too easy. I think induction is the core of it, and electromagnetic waves, Maxwell's equations, we will stop more. We'll stop more for details. But before those, we will go through these chapters really quickly so that we don't miss any important stuff that we can learn from Resnick. So Resnick should give a really good background. But the first chapter I really looked through, and I didn't find anything that you might be missing because everything seems very logical. Conductors, insulators, charge. And so, for instance, Coulomb's law, right? Force between two charges. And even in the Prut, they explain, they compare electrostatic force with gravitational force, and they explain that their scale is different, meaning that if you put two materials and account their electrostatic force and both gravitational force, electrostatic force dominates, right? Assuming they have same mass and same charge. That's why gravitational force only accounts for planets or huge materials, not for small materials. But nevertheless, unless they tell you to ignore, you shouldn't ignore, and you have to solve. It's just the scale of electrostatic force with the scale of gravitational force is incomparably large. So that's the first thing. And there's a shell theory, so these two are very important. The second one is easily explainable with Gauss' law, but this first one should be important, right? A charged particle outside the shell. So imagine you have a shell, and then you have another charge Q2, and this is Q1. So this is a shell. Inside is hollow, right? And charge is Q1. So what it's saying is a charged particle outside the shell with charge uniformly distributed on its surface. The shell is uniformly distributed, its charge, and on its surface is attracted or repelled as if the shell's charge were concentrated as a particle at its center. Типа, как это point charge, когда you are calculating its electric field, right? E as a function of R, you think the shell as if it's a point charge. It doesn't matter, like similarly, uniformly distributable case. Конечно, когда it's non-uniformly distributed, this side has more charge than the other side, then of course the electric field will not be uniform, and you cannot account it as a point charge. But this is for uniformly distributed shell. So at distances larger than its radius, you can think of it as a point particle. And the second one is Gauss' law. It's saying if you put a charge inside a uniformly distributed shell, again, let's say here you have a charge, the net force is 0. And it's you can prove it with Gauss' law, like inside, let's take this radius, and the electric field times dA is equal to Q enclosed divided by 0. So in order for this charge to feel the force, it should feel electric field from outside. So we cannot account for its own charge. So, and since there is no charge other than this, there is no electric field according to Gauss's law. But the shell theory is basically explaining when you have uniformly distributed spherical shell, and you put any point point charge, its electric field is still, I mean, electrostatic force is still zero. So two things, I mean, always keep in mind. I think those two are the most trickiest ones. Besides that, everything is logical. It's simple vectors, simple geometry problems. And you can solve all of the problems, I think, without any problem and without any issue. Yeah, these are all like equilibrium problems, right? Gravity and electrostatic repulsion force, two dimensions. I think you can easily solve these. And this angle depends on those tangent, simple angle formulas. Electric fields. This is a little bit trickier, but I think you know them. So electric field is basically electrostatic force divided by unit charge, which is 1 coulomb. That's the definition of electric field, and it's a vector, right? So one thing you have to know is positive charge emanates from electric field emanates from the positive charge, and the electric field goes to the negative charge, and it can be explained with potential, right? You have high potential, electrostatic, goes from high potential to V low potential. If you have potential A and potential B same, electric field is equal to zero, right? And this is a well-known thing because electric field is equal to delta V divided by D, distance between them. So in order to feel electric field, you have to have change in electrostatic potential at 2 points. So it's very similar. You have two exactly same mountains, and you put the plate. If you put a particle at the equilibrium, it doesn't roll anywhere because the same height. But if you have high and low, and you put your particle, of course, it will roll from high to low. It's a similar analogy. Like it's in nature. Nature works like this in electrostatic sense as well. So that's it. And whenever they talk about electric field, it's always Gauss's law, right? So, but Gauss's law, derivation of Gauss's law is really well explained in Griffith. I think I will explain it when I go through the Griffith, but there is one more thing is dipoles. Dipole is basically a combination of plus and minus charge separated by a small distance d. At infinite distance, it should be, apart from its linear term, all its terms will be zero. So this is basically solving it, and you know this expansion, right? Binomial expansion. When you have 1 plus or minus x to the power of n, you can expand it without any approximation. You can expand it as binomial expansion, and x plus 1 over 2 factorial x squared and blah 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 plus higher order terms. And when x is small, right? X is small compared to 1, or you can say x is much smaller than 1, then it will be basically this. Or sometimes they take up to second term. So it depends on the problem. Like unless it's stated, you should take the first one, 1 plus nx. But sometimes in the problems in Jaltikov or any other competitions like Olympiads, they mention to take up to the second order. In that case, you should take up to the second order. But still, this is the approximation. And it usually works like if 1 plus x to the power of n converges to, let's say, 3.86. When you do this kind of approximation, you will basically get 3.84 or 85 like this. Like it's basically, or even closer to this, like 3.85 something, you know. So depending on the conditions, I mean, approximation is very, when these kinds of approximations are made, they are very close to the real value. So you're not basically compensating much. And here it's basically you're solving electric field for R plus and R minus, and they are dependent on z-axis like this. You can instead of z, you can direct to other angles as well. I'm sure you understand it very easily. And when you do combination, you will get this result, electric dipole. And one more thing is electric dipole direction is from negative to positive. It's opposite to the electric field direction, right? Always remember that. I mean, its value is QD, so it's not charge, but it's charge times distance. And uniform charge distributions. I think you are comfortable with integrals, right? How are you feeling with integral uniform charge distributions like this? Эле интегралдарды жакшы эле неме аласың да, разбираться этесиң да, мондай uniform charge distribution'дарда.
Интегралы у меня нормальные, но в очень сложных могут быть немного ошибки.
Например,
Ну,
например,
вот
у тебя есть line charge density, let's say, lambda is equal to q divided by some length L допоела, да? И это R given, дейли. You can find easily the electric field, right, in this kind of scenarios.
да, ну вот то, что именно в этой книге представлено, там, в принципе, легкие интегралы, но
Хорошо.
мы как-то решали какой-то ИФО, и там был очень трудный интеграл, и я его не решила.
Хорошо. So these types of integrals are easy for you then.
Да.
Хорошо. Ну, тогда it's a good news if you can understand. Ну, circle да постоянно имей в виду, да, ария қалғанда circumference аласың да, дельта арға multiply қыласың да. So those stuff. And this is also important to note. So when you have finite radius disk, its electric field at point Z radial outward. It depends on like this, but when radius goes to infinite, limit алғанында, all part 0 болып кетеді дағы. Sigma over 2 epsilon 0, which is basically infinite sheet. So I'm not thinking you will have any problems. The only thing is ол дипольды біраз жақсырақ түсініп алсың керек, да? Torque is equal to P cross E дегендерді. Сен кросс продукттарды жақсылай білесің?
Можете повторить?
Кросс продукттарды жақсылай разбираться етесің бе? Cross products.
Да, вроде.
Right hand rule, да, типа how to find its direction and so on дегендерді.
Да.
Хорошо. Yeah, then I would say memorize this torque equation, P cross E, potential energy minus P dot E, just in case, because it may hurt if you don't remember this. And solve many problems with this. Because those are tricky ones. Besides, I mean, electrostatic field негізі единственное, ошол мен корккан жерим, ошол жер болот. As you may have noticed, they didn't discuss any conductors yet. And these are all solvable. I think you can solve them, all of them, without any issues. So let's proceed to the next chapter, which is Gauss's law. Gauss's law, the главный поток это area vector менен ошол field vectorдун dot product, which means only their parallel axis, parallel terms count, мынаунун E cos theta, мынаусу эле count болот, да? И area vector, то есть dot product, да? Ошол потоктун ошонусу важно. Потом with that you can define, and Gauss law can save a lot of time for you. integral form is quite easy. Q or epsilon naught. I think you can learn them, and I mean you know them. There are three types of symmetries, right? There is spherical symmetry. There is cylindrical symmetry, and there is spherical, cylindrical, and plane symmetry, right? So for cylindrical symmetry, you should have all cylinder or line charge. In these kinds of cases, you have you use cylindrical symmetry. But if you have spherical geometry, be it shell or spherical volume, you will use spherical symmetry. And for plane materials, you can always use plane symmetry like this, or even circular cylindrical. Cylindrical была іште қалатқа, бірақ типа любой бір бокс, пилбокс деп қояды, гаусшен пилбокс алып кете тұрсың болады. Сен бұл симметриялар жақсы білесің, ә?
Ну, не знаю, мне кажется, что не очень хорошо.
Тогда it's very important that you understand these three symmetries really well. So let's solve problems then. Анда ушул жерден көп уақыт біраз құрашу керек, анткени it's very important мына оларды түшүнүш. Gauss law. No, Gauss law'дун негизи интеграл форма эмне? We will derive it when we go through the Griffiths, but its real result is what? E times dot product with delta area is equal to Q enclosed in that area. So it's whatever charge you have within that area divided by epsilon 0, да? This is Gauss law equation. Ол обычно circle law. Бұл дегенде closed area деген түсіндіреді. Closed area. And this is the Gauss law equation, and let's solve for symmetries. Симметриялар қайсылай береді? Ну, первый мынау обычный line symmetry, cylindrical symmetry қарайлы. Cylindrical symmetry, imagine you have infinitely long wire like this, and its line charge density is, let's say, Q divided by L. Ну, обычно Q divided by L daily. It's asking electric field at any point R distance from the wire axis and R distance. No, when you have a line charge or cylindrical charge, you immediately use Gauss law with cylindrical symmetry. So you basically take Gauss surface like this, right? It goes infinity to plus infinity and minus infinity. So like this, you take it. And the electric field, you know, from plus, it emanates radially outwards. So the electric field is like this, right? Here it's like this. Here it's like this. Here it's like this. So electric field at radius R times dA is basically circumference multiplied by L, this surface, right? This surface is your area. The electric field, the mole area and surface, is 2 pi R is your circumference, and L is this distance. L is this distance. So you are basically taking this area, and the electric field is everywhere same because it's equal at the R distance on all surface points. 2 pi R. L is equal to what? By Gauss's law, it should be equal to Q enclosed, which is lambda line charge density times L divided by epsilon 0. E at radius R is equal to lambda divided by L, and L cancel up with it. 2 pi R epsilon 0 R hat radial outward. So electric field, and I can is values only lambda or 2 pi epsilon 0 R. This is how you use cylindrical symmetry then, потому что it requires cylindrical symmetry to solve these types of problems. This one makes sense, right?
Да.
Хорошо. Yeah, this is how you use cylindrical symmetry, so you should know them by heart. The next thing is spherical symmetry. You use them when you have spherical charge density or spherical geometry, and they used it here. This is plane symmetry, and this is spherical symmetry, да? Но spherical обычно, қандай случайларда болады? Обычно you have uniform charge density, rho дейді, да? Imagine you have spherical insulator, but its charge density is rho. Its value is Q overall charge divided by its volume, 4/3 PR cube, да? PR cube. Let's say it's uniformly distributed along its volume, and it asks electric field at any point radius R, inside and outside. So you should solve for basically two parts, inside and outside. So here, since it's spherical geometry, you should use spherical symmetry. That's the easiest way. I mean, you don't have to use it, but that will make things very easy. And if you do that, let's say, again, Gauss law, that E multiplied by dA is equal to, both of them are vectors, is equal to Q in divided by epsilon naught. EDA at radius R, again, it's electric field at radius R is same at all points, right? Multiplied by, area is 4pi r quadrat, 4 pi r squared. And they are electric field and area vector, they are all parallel to each other, right? So at this point, electric field is radially outwards. And if you take small area like this, its area vector is also radially outward. It's in all cases, it's the same. Area vector and the electric field vector, they are all same. So that's why you are just multiplying. Dot product is basically this. Is equal to Q enclosed is rho multiplied by charge inside this sphere, right? Inside this dotted sphere, it's 4/3 pi, no, pi жоғарыда болуш керек, мынау емес. 4/3 pi r cube, small r cube, divided by epsilon 0, да? Epsilon 0. So this is Q in, it's epsilon 0. And if you do this 4 pi and 4 pi cancels out, r quadrat and r cube cancels out. So E at radius R is equal to basically rho R divided by each epsilon 0, да? R hat direction, because it's electric field's direction is radially outwards. So if you have negative charge density, it will be radially inwards instead. But you understood. So electric field is, as of inside the sphere, it's basically radially increasing until it reaches so y-axis is electric field with respect to R, then x-axis is radius. So if you plot electric field with respect to R, it will linearly increase like this. It's proportional to electric field is proportional to R, linearly increase, and then it will decrease like this, proportional to 1/r quadrat when it reaches the overall surface. Why? Because when it reaches the overall surface and when your radius is here, if you apply Gauss law again, your E times 4pi r quadrat is basically, Q in is at this point is basically rho times 4/3 P большой R куб, деленное на epsilon 0. И rho большой R куб, мол, просто Q, да? Q divided by epsilon 0. Получается, electric field, when you are out of the this sphere, it's basically Q divided by point charge, да? 4 pi R куб, R квадрат, epsilon 0, да? Поэтому until it reaches radius R, it's linearly increasing and like this. And Griffith Tesla görчү also, Griffith, they give problems where your rho is dependent on R or KR квадрат или 1 over R сияқты немелер береді да, proportionality'лерді береді, и ошол кейстерге да чыгарасын. It just takes integral да. But you understood the logic, right? Whenever you have spherical geometry, you immediately stick to spherical symmetry. Is that clear so far?
Да, все понятно.
Хорошо, that's good. I mean, did you know this stuff, or is it something new? Or how well you knew this stuff, if you knew?
Я знала, но я просто знала вывод. То есть именно вот этот график знала, и то, как он будет увеличиваться, а потом уменьшаться, это знала, но сам вывод этого не знала.
I see. So yeah, that's good then. Griffith, мен саған задание берейін. Ну, I really came to the conclusion that to be really comfortable with electrodynamics, I think students should solve all Prut as well as Griffith and Purcell as well. Of course, initially you should solve all of the Prut, right? Сперва полностью Prut до конца чарпишь керек. А потом, я думаю, после того, как вы закончите Prut, да, Griffith delay и Purcell delay, quickly you should go through the problems and theory quickly. Most of the things you learn from Prut will be there, but some of the things might be new, да. И ал дағы бір extra dimension береді, да, чтобы вы смогли сразу перейти к solution, да. Типа, тағы бір задачаларды оңай шығаруға бір логика береді, да. Ну, конечно, көп задачаларды шығарышқа тура келеді параллельно. Получается, мен главный ойым не болды, conclusion. Students should solve Prut as well, Griffith as well, Purcell as well. But the more you solve, the less difficult it becomes. Типа, сен Prut'ты шығарып біткеннен кейін, Griffith менен тиги Purcell'ды шығарып намного жеңіл болады да. And you can go through them very quickly. Within a month, I think you can easily finish both Griffith and Purcell as well if you finish Prut. But all of them complement each other. I think they replace, but at the same time they complement as well. Complementary деген quality'ni білесің да. Типа, бири-бирин толықтайды да. Но Griffith'те, ну, мен азыр Griffith'те ачайын да, really quickly. Where is Griffiths? It's here. Griffith'ten bir-екі задача көрсетіп қояйын, really quickly so that you know what I'm talking about. Vector, Dirac delta function. Where is that? Magnetostatic stimulus. Special techniques gadget 8. Наверное, страница 70 примерно. That's my guess. Pointer. Да. Almost got it right. Ну, Gauss law, нормально, да? Spherical symmetry объясняет. Что задачалар бар, сон. I would suggest you to solve this problem. 2.15. Your rho is dependent on k over r quadrat. K is some constant. Instead of your rho was constant in the first case, right? Do you remember? It was Q deléné на third PR cube. No, overall volume, 4 over 3 PR cube получил. It was constant. A mole case, it diminishes as a function of 1 over r quadrat. Ушундай задачалар бар да. Типа, it just complicates, it just requires you to solve a integral. Жогоркусунда KR экен. All to the KR mode. No, I would suggest to go through these problems very quickly. You can easily solve these. And these will give you really good spherical symmetry insights. So let me type it 2.14, 2.15 on Griffiths. Griffiths 2.14, 2.16, Gauss's law, spherical symmetry. Эми бийиктиги өтсөк, дальше. What you should know after this. Ну, например, мол кейс, да? Под каким-то углом болгондо only parallel parts are important. So in this case, it's E times sine theta part is the parallel to the surface, да? Не, cosine part, да? И типа normal дегенде могул normal upside болуп атат, а electric field'дын direction'ы могу cosine алганыңда могул direction'да болот. Получается, the flux will be negative, да? Потому что the electric field area vector is up, да, normal vector. Обычно normal vector n vector алышат. Your electric field vector is down. So E dot n will be negative, да? So those are the stuff that you should pay attention to. So your flux will be negative in this case, in the first case. So I really recommend you to go through these problems really quickly. Онда да бир, например, бир задача бар, да? Не дейт? If you have a proton and it's some distance away, it's d over d above a square. Но мындай задачаларда you basically don't have to, I mean, you can solve it with integral, да? Типа, мол, азимутальный полный angle, полный ария канча алат, ошону санасаң болот, да? И electric field is in this direction, your area vector is radially downward, и могул угол тета менен типа E dot dA деп көрүп чыгарсаң болот. Косинус тета менен чыгарасың, да? Под углом косинус. Потому что cosinus matters for the flux. But easier way is to use the knowledge. If you enclose this over all directions like this is basically cube, да? Yeah? Могул бир cube, да? Негизи Q over epsilon 0 is your E times area, да? То есть total flux. The total flux is Q over epsilon 0, да? Получается, the total flux-тун 1, 2, 3, 4, 5, 6. 1/6 мол ареядан өткөн, да? If, I mean, your cube basically covers all of the flux, да? 1/6 мол blue box-тан, blue square-ден өтөт, да? Ошол нерсени, да, типа 5 over 6 Q over epsilon naught is your flux through this blue square, да? Но обычно мындай задача берилбейт. Типа, it's not too academic, да? I mean, what you will do with knowing flux through this area, it doesn't give you anything like physical value or meaning. But it's a good way to think. Like sometimes instead of solving the integral and doing cosine and all those like from d minus d over to plus d over 2 integration, you can basically use your symmetry analysis and then solve it very quickly. These types of problems. Yeah, this is very typical problem. I think this was even, I mean, отбордо да бердим беле ушуну. Отбордо берген жокмун, бирок республиканскийде берген ушу задачаны. Именно ошого окшогон задачаны. And it's very meaningful. Но единственное бул жерде you have to know one thing. Here we are thinking uniformly distributed spherical shell деп атамыз да, rho, да, или мол жерде sphere, да, uniformly distributed rho. А если бұл conductor болса, if it's a conductor behaves completely differently. This is insulator, да? Без шансов insulator болуш керек. Insulator болбаса, uniformly distributed болбойт, да? Conductor эмне үчүн uniformly distributed болбойт? Анткени conductor, they have free electrons. And because of those free electrons, electric field inside the conductor will be zero. That's because of the Maxwell's equation. We will derive it later on. So what does it mean is, as soon as you have external electric field, plus charge will be on this side, and minus charge will be on this side. Is that the electric field goes through this? No, minus charge will be polarized on this charge, and plus charge will be on this side, right? Right. So minus charge will be polarized because they have infinitely many free charges, conductors, and induced electric field will be in this direction, and that induced and external will be cancelled out. So that's how you know electric field inside the conductor is zero, да? Получается, если у тебя кондуктор болса, онда сфера болса, кондуктордун бүт немеси, charge заряды surface'ке чейip берет да баары. I will give you these problems that we made for республиканский олимпиада болуш керек же даже отбордун задачалары. Ушул задачаны берем, сага жакшы разминка болот. Типа кондуктор менен инсулятор совсем башкача behave кылат да, ошону четко мындай билишиң керек, да. Conductors, all the charges are at the surface. Insulators, it can be uniformly distributed. This is insulator for sure. 52 shows this and so on. Like it didn't mention, but it's here. The volume charge density of a solid non-conducting sphere. So that's why, like, non-conducting sphere сыяктуу нерселерде моундай бир relationdарды жазсаң болот. As soon as it becomes conducting, all of the charge will go to surface. So that's the distinction between them. Могул жерде мисалы, it's obvious you should use cylindrical symmetry and so on. Electrostatic potential, да, эни билишиң керек. What you should know. It's one thing you should know is conservative fields. Have you heard of those? Conservative. Типа gravitational force и electrostatic force, да? F, G, тоже F, E тоже. Буладын баары conservative force, да? И conservative force'тар эмне менен отличаться этет? Force is equal to minus gradient of potential, да? U, potential energy, да? U. Ну, вектор. То есть conservative force'тарда моундай бир relation роль ойнойт. No, minus емес, plus лекен. Force is equal to this. То есть получается electric field is equal to gradient of V, да? V. И бұл conservative field, главный distinction не, they are path independent. Conservative field, да? Ушул conservative тууралуу да бир separate лекция кылышым керек, анткени this is quite tricky and it's vector calculus да бул. Бирок главный билишиң керек болгон, it's path independent, which means you have two charges plus and you have electrostatic potential, equipotential lines кайсы жерде турат? Radius R да турат, да? Radius R. Across all this radius, the potentials are equipotential. Да? Могу point potential менен, могу point potential 1, да? These are equipotential lines. And могу делем, so equipotential, да? The second. Well, let me draw this with different color. Типа могу эки линия. Могу is, let's say, positive болгон үчүн бул V higher болот, да? Мына blue болсо V lower, да? V lower. Бирок Могул red менен blue бүт poinттарында same potential да. И тиги conservative force болгонун мааниси главный, типа main point of that, what is the case? The case is the work done to draw one. Let's say you have positive charge here and you have another charge, let's say the black. This is another charge, okay? This is Q2. And the work done to bring this Q1, Q2 from point here to here through this ray, like this direct way, and through this rotation will be the same. Да? Типа могул биринчи pass менен экинчи pass берген work is the same because it's path independent. Да? So what's the work? Work is basically Q times delta V. Да? Q times delta V. Or, I mean, in other words, force is equal to, work is equal to force times dx интеграл, да? D-work интеграл, да? То есть, получается, conservative field дегендин главный маанисинде fast independent ошол. Получается, сен initial potential менен final potential деп билсең, that's enough to solve for the work, да? Эмне if it asks to solve the work done by someone to bring Q2 from this point to this point, it will be basically work will be equal to Q times delta potential. Да? Delta potential is basically potential at this point minus potential at this point. Sure. Conservative field is separate lecture details. It's very important to understand. But just remember that electric field, gravitational force, central force'тардын баары conservative. Обычно central force деген типа планетарный модельге түшкөн бүт эле форстар немелер да, conservative. Бул gravitational force is conservative, electrostatic force is conservative, and so on. Friction force is not conservative. Friction force, мисалы, this is the friction force, да? You are taking it. Work done by friction is what? Normal force times coefficient of friction, which is friction force. It's if you are moving in this direction, your friction force will be in this direction, right? And then its work will be F times this distance, да? Displacement, distance дейсің, обычно distance болуш керек, delta x. И friction'да, мисалы, сен ушул path менен барсаң, же болбосо могул distance менен моундан айланып келсең да, ушул поинтка, совсем башка бир amount of work кетет да. То есть the heat that's dissipated through this way and through this way will be completely different because it's not path independent. Because friction force is not conservative. That's why you cannot write friction force as a gradient of some potential scalar function f дейсің. Ну, типа potential v, да, electrostatic potential is some scalar function f, да, обычно. Ну, немеде calculus, да, f деп ойлабасың, да. It's just a function, да, it's just a number. It's just a number that depends on x, y, z, да. А сенин electric fielding, yeah? Electric field is, because it's conservative, it will be equal to gradient of this function f, да? X, y, z. No, f in this case is electrostatic potential, да? Same for the gravitational potential as well. But friction is not conservative, and because of that, you cannot ignore friction forces past that. Типа path A менен path B эки башка work кылат да, friction force да. Ошо. Did they explain about that? Equipotential surface territorial work done by it. The equipotential surface there, obviously, because it's conservative. Surface içinde null point, null point kalıp келгені null work, no work is done. That's quite important, right? Потому что delta V is equal to 0, да? So your work is Q times delta V is equal to 0. If you are, imagine you are, this is the equipotential line and you just moved from your particle from here to here. Even with this line, like this, you moved with this helical path and to here. But your eventual, like your final position, this is B, this is A, lies at the same potential line, which means potential A is equal to potential B. You didn't do any work in both cases, this path A and path B, because it's conservative field. So that's critical to understand. Bunu білчү Эльдана?
Нет.
Нет? Хорошо, тогда you learn something, да?
Да.
Да. Does it make sense?
Да.
Да, хорошо. So it's really good to know. Мынау жерде түшүндүрүп берет так да? Path and field line and so on. No, типа checkpoint только. The figure here shows a family of parallel equipotential surfaces, типа equipotential surface да? 40 volts, 50 volts, 60 volts. And 5 paths along which we shall move an electron from one surface to another date. Электронду 5 түрдүү жол менен change кылдык дейт позициясын. A, what is the direction of the electric field associated with the surfaces? What is the direction of the electric field in this case? Electric field will be from high to low, да? Electric field. And fortunately, to our case, they're uniformly decreasing. So electric field will be same in all cases, right? In this direction. A is solved. B, for each pass, is the work we do positive, negative, or zero? Каждый паска positive, negative, or zero дейт. Первый пас from 80 volts to 70 volts. Типа delta V is equal to 10 volt difference voltage, да? It's going down. Второй пас same. Третий пас 20 volts, да? Третий пас Четвертый пас minus 10 volts. Ну, если V final minus V initial day true амылчылсаң, анда opposite, да? То есть delta V in this case is minus 10, да? Minus 10, minus 10, minus 20, plus 10, minus 10. No, I mean for each positive, negative, or zero. So work done will be, what's the definition? No, electric field times ts, negative can, equipotential. По идее, логикаға салып түсінсең болады, мына қандай қылып логика салып түсінсең болады. Let's try to put into the logic. So you have high potential and low potential. What will be the work that you do when you are moving the charge from high potential to low potential? And is it electron or it's electron? So if you have electric field in this direction, and if your electron is negatively charged, your force, electrostatic force will be in this direction, да? Because force is equal to minus QE, да? Minus Q, it's electrons charge minus, да? E. Получается, сен point 1-ден point 2-ге алып келе атканында, you are working against the field, да? It's quite tricky, negative, positive деген понятиелер. For each of the paths is the work done positive, negative, or zero. Rank the path according to the work we do. Greatest first state. Let's solve and then we'll take a look at the solution. work is equal to force times delta x then dx integral for q delta v. No, delta v and the integral integration q delta v. For electron, this will be negative. Negative. Q. So in the first case, from 1 to 2, its potential is minus 10 volts, delta V. 70 minus 80 is minus 10. The second case as well, minus 10. The third case is minus 20. The fourth case is plus 10. The fifth case is minus 10. So minus 10 times minus electron. So the first one is we are doing positive work, positive, 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 negative, positive. It's my understanding because we are doing, this is minus 10 volts and this is minus some negative charge. Minus positive, 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 negative, positive, and rank the paths according to the work we do, greatest first. So greatest will be number 3, right? Highest number, and then it will be 1, 2, and 5 the same work. So 3 and 1, 2, 5, and then 4. This is our ranking. No, 4 даже negative, потому что we are going backwards. Let's take a look at the solution. I don't know the solution, but checkpoint chapter number 24, 24 كنا checkpoint 2, 24. Check that. Think, analyze. 1, 2, 3. I don't think they gave it here. Checkpoint and solution I'm sure they have the solutions. Maybe it's at the end of the chapter. No. Ладно, короче, checkpoint and solution пока точно Halliday Resnick. I'm sure I saw, I remember there are some solutions for the checkpoints, but where are they? I'm not sure right now. But Broccoloic and Chinsangrek, what we did here. Where were we? Here. Here, yeah. And the next thing is potential due to a charged particle. Главное blessing, да. Но главное potential the minus M, potential the minus C. It's the amount of work that you do to make that configuration. Сөзім не жатқан, шындатасың? The amount of work that you do to make that configuration. Let's say you are putting positive charge here and you have no charge around it. You are basically doing no work because there is no delta V. Delta V is equal to 0. You are basically putting one single charge. But when you bring another charge, let's say minus charge, at some distance to this, r, then basically you are working against the potential that this positive charge produces around it. And that usually is counted from infinite distance. Да? То есть V R by positive charge is Q divided by 4 pi epsilon mol R. Да? Epsilon mol R. At infinite distance, this is 0. But anything that's smaller than infinite, there is some finite potential. And the work that's done is work is equal to Q delta V. Да? Получается, you have to find V final minus V initial. Да? И обычно алгоритм шығады, ал обычно electric field dr, да? No. From infinite to you are basically calculating from infinite to r, да? No, final, если короче, definition ушел, негізі. If you come from here, that's how you calculate electric field from electrostatic potential. So electrostatic potential, if you reverse it, it's basically this. That's how you find it. And in general, as I said, electrostatic potential is basically, or electrostatic potential energy is the energy of the configuration. For instance, you have a spring. A mass spring system дал, да, допустим. You have a spring and you have a mass like this. If they ask what's its potential, it's basically potential of this configuration, да? Да? At equilibrium, here, stretch is equal to 0. Velocity is fine. No, let's say if you push it to this position, x distance also, all position, да, let's say your kinetic energy is 0. Да? Бұл системден, да, бұл неменің configuration potential energy spring energy да, основном, да, 1 over 2 kx quadrat. Да? And when it reaches back to equilibrium, you have no spring energy, but it totally transfers to kinetic energy of the block, да? 1 over 2 mv quadrat. And this oscillates back and forth. At the maximum stretch, it goes all back to spring energy. There is no kinetic energy of the block. Its speed is equal to 0. And then it oscillates back and forth. It's quite similar in this case, like in potential charge system. There, if you have many charges, then potential energy is basically potential energy between these two, combinatoric, between these two. So you are basically putting this without any work, and any charge that's you are putting after this is basically counted interactions between these two, and so on. And that combination is actually done Griffith'te жақсы түсіндірілген, шындасы, бірақ бұл жерде түсіндірілген емес болуш керек. So you are basically having two basic definitions. One is electrostatic potential is basically the amount of work that you do to bring charge from infinite distance to a certain position, да, only. Second is they are actually related to each other. Potential energy is basically energy of the configuration, energy of the geometry. So those two things you should remember. Positively charged particle produces positive potential, and negative charged negative potential. Бұлардан, я думаю, ты уже знаешь. Dipolden немесе potential. Dipolden potential, it's also solvable. Biraz interference ұқсап береді екен, бірақ it's not that similar. So again, you use the approximation like this. Binomial expansion қолданса болады бұл жерде. Бірақ мол уравнение точно көргенсің. Мол немеде көрген. Prut touch. Although they didn't derive it. Line charge density, ты же знаешь. Маларды уже знаешь, да? То есть получается key point dv is equal to 1 over 4 pi epsilon naught dq деленный на r, да? То есть dq charge-тан at distance r, its potential is this, да? And it's scalar. The electric field is vector, да, electric field. Либо radial outward и inward, depending on the charge of this point charge, да? Типа dq-ның charge негатив болса негатив r болады, positive болса radial outward болады. Potential болса it's scalar. So there's a quick distinction between those two. Типа елестет, you have positive charge here, you have negative charge here. So at the midpoint, if they ask electric field, the electric field is not zero, да? Типа positive charge бұл жаққа push қылады. It's electric field, да, from positive. А negative charge болса өзіне pull қылады, да? Electric field negative. Electrostatic potential is zero. Why? Because you have basically, from this, you have basically minus kq divided by r over 2, да? Distance r over 2 деп қоялық. Ол болса k plus q, да? Заряд plus q divided by r over 2. И when you add them up, you have zero. So the electrostatic potential at the exact midpoint is zero, but the electric field is not zero. So that's the distinction between being vector and scalar. So you should be careful when you deal with those electric field and electrostatic potential. One of them is scalar, one of them is vector. Okay, dokie, these combinations mentioned already. These are all solvable. I don't think you will have any issues with these, to be honest. Capacitance. So far, so good. Типа, симметрияларды қарадық, potentialды қарадық, басқасын қарадық. Эми, capacitance-ға келдік. Capacitance бұл емкость, да? The amount of charge you can fill to the certain geometry. And usually, the way you find capacitance is basically Q divided by delta V. То есть definition let's see that. And with this definition, you can find any type of geometry. Типа обычно біз нені білеміз? Parallel plate capacitor'ды білеміз, да? You have parallel plates like this. One of them has minus Q, another one is plus Q, да? Обычно. Ну, задачалар шындай ғой. Конденсатор с параллельными пластинами, да? И distance между ними is D, да? И между ними sometimes they put dielectric. Epsilon болушы мүмкін, d epsilon болады. No, epsilon болса, epsilon is what? Epsilon is basically relative permittivity times epsilon 0, да? Same thing. So usually what they do is basically C is equal to epsilon 0 area деленный на d, да? А dielectric болса epsilon area деленный на d, да? То есть dielectric қойғаныңда аны емкости көбейіп кетеді, да? It will have more capacity to store charge. И обычно when it stores charge, it stores potential energy, да? Типа electrostatic potential energy. Капаситордың potential energy'сіне Q квадрат деленный 2C, да? 2C. То есть емкость, it stores electrostatic charges, basically, or electrostatic potential energy, the same thing. Но когда у тебя when you have different geometries, imagine you have like this spherical two concentric materials, conductors. Radius inside is A, outside radius is B. And they may say, what's the C for this case? And imagine inside its charge is Q, outside its charge is 0. Obviously, there will be electric field, And then, I mean, you don't have easy equation like this, but the way to approach this is to find potential difference between A and B, between these two, and then divide by the charge. That gives you C. And actually, we will solve in one of the examples below. I mean, I'm sure they solved it. Ушундай кейстерге, типа ушундай кейстерде you cannot rely on this type of equation, but you should rely on the definition of capacitance, which is the charge it can store divided by potential energy difference. So geometry. Oh, here is equal to CV in general. Calculating the capacitance, the given equation. Yeah. I really recommend to go through it. Yeah, this is what I was telling. So since it's conductor, what's the case? Just quick note. Since the second shell is a conductor, electric field inside this conductor should be zero, which means electric and negative charge will be on the inner surface to neutralize the electric field coming from the positive net charge of the sphere inside. So basically, total charge, if this is Q here overall, the total charge inside this should be minus Q. No? Why? Because of Gauss law is equal to Q in divided by epsilon 0, да? Should give you 0. Получается, overall mole conductor enclosed кылган bir surface алсаң, Gaussian surface, да? Spherical surface. And you take the area plus Q менен no surface in the inner surface in minus Q экөө бири-бирине add болуп 0 болуш керек, да? Ошентип анан you get basically 0 electric field inside the conductor. So this is just a quick note so that you understand it. Just explains why you have minus Q. So yeah, this is how they computed electrostatic potential for this geometry. And then, as I said, when you calculate the capacitance, it's basically Q of the system divided by the electrostatic potential across these two area surfaces. That's how it's given. Spherical capacitor тоже ушундай болуп табылат. Бул cylindrical capacitor окшойт, походу. Yeah, first is cylindrical capacitor, the second is spherical capacitor. I really recommend you to go through this. I'm not sure if they gave such a problem below. And then, of course, you have to know addition of capacitors in parallel, in series, more series, more parallel, how the charge will be distributed in each case. I mean, they are not difficult. Capacitors that are connected in series can be replaced with an equivalent capacitor that has the same charge Q and the same total potential difference V. Normal case that is derivation it's very important. I don't want to spend time. Единственное нәрсени түшүндүргүм келет, charging and discharging a capacitor деген бар. The work done to charge a capacitor. Батарея койдум. Initially it has at arbitrary time daily, it has V, which is basically Q over C, Q over C. And you are trying to put more charges. Типа позитивте, могул жерде positive charge кетип атат да. Бул жагы негатив, бул жагы негатив charge кетип атат. Получается, the more you charge, the harder it gets, да? Потому что you are basically working against the electric field here. So what's happening is work done by this to charge it is basically electric potential of this capacitor times dq, да, is equal to the work and you are basically charging it from 0 charge to Q charge. And V is basically Q over C, и dq is equal to d work. Получается, из-за этого шулердің Q квадрат деленный на 2C келеді. То есть конденсаторды 0-дан Q-ға чарж қылыш үшін Q квадрат деленный на 2C work жасашын отыра келеді. And that's, as I explained earlier, it's basically similar to mass spring system. When it's fully charged, it's basically fully kx-ге не болған, да? Kx квадрат деленный на 2C-ге 2-ға push болған бір неме сияқты, да? Push болған бір spring сияқты, да? When you release it, especially it's obvious when you do LC, да? Мынау жерге бір катушканы қойсаң, индукторды. Electrostatic, мынау жерде purely all of the energy is electrostatic energy. Q квадрат деленный на 2C, да? U is equal to Q квадрат деленный на 2C. It will oscillate between electrostatic energy and magnetic energy, which is U is equal to Li квадрат деленный на 2, да? Oscillate болады, да? It's basically mv квадрат деленный на 2 бұл kx квадрат деленный на 2, да? Пополам. They are very similar. So, yeah, these are the things that you need to know about capacitance, but the key thing, everything else is actually quite understandable. I think you can understand. Besides, the one that's tricky is this one, as I mentioned, finding the capacitance of different geometries. For instance, in some Olympiads, I saw the problems like you have potential here, VA, да? VA, a potential here, VB, и random бір мындай geometric space, да? И they asked to find the potential of this capacitance of this C. Оны қайтып аласың, да? Осындай случайларда не қыласың? Сразу дельта V аласың, да? Дельта V. C times delta V is equal to Q, да? Получается, C is equal to Q деленный на дельта V, да? Шынтөлі тап болсын, да? И бұл көп tricky geometrilерде шындайлы келеді. Потом уже сұрайды, типа, what will be its electric field, how it will be, and so on. Electric field линиялар мондай болады, депші. Шыларды уже полный жай. Дальше дейінгі пункттарына шығарасын, да? И how its current will be, and so on, депші. Мол, если мынау in between some dielectric material қойсың, жоғылсың, бір кондуктор қойсың, current қандай жүреді, депші. Шылардың барын чарж қатыра келеді. Но capacitance тау үшін Q деленный на дельта V қылсын, capacitance жаға сразу. That's how you find. And AFO, IFO-ларда обычно көп шығады, шындай зарычылар. Yeah, these types of problems, I really recommend to go through these problems, especially 20s problem, this interesting, but you can solve it. This combination, charging and discharging, dielectric комбинацияларда, 50s. Current and resistance, I don't think there is much to worry about it. The only thing is I is equal to NQVDA, шон четко біліп алып. Current, let's say you have a pipe, да? Only pipe бар, turbo. И you have drifting charges. Velocity drift is D, and their concentration is N. Area, cross-sectional area is A, and the current is I is equal to NQVDA, да? NQ velocity drift A, да? Шын четко біліп алып. Жаттап алсам болады, мен жаттап алған болсын. I is equal to NQVDA. It's very useful to remember this. In many problems you will use it. And generalized Ohm's law деген понятие бар. Ал не? Ал current density деген понятие бар. Current density is a vector quantity, which is I деленный на cross-sectional area, да? I деленный на cross-sectional area. This is current density. That's why J is equal to NQVD instead of A düşіп қалған, потому что you divide by A, да? И generalized Ohm's law'ды не дейді? is equal to sigma E, да? This is generalized Ohm's law. Типа Ohm's law не? Ohm's law is equal to V is equal to IR, да? That you know. V, ну, V вектор емес, по идее. V is equal to IR. А mol J is equal to mol equivalent equation, да? Просто mol is generalized. Generalized, meaning it's more universal. And you can deal with electric fields, conductivities, resistivity stuff. In this one, you basically take resistor as a bulk, черный ящик сияқты аласың да. You have like this electrostatic battery or some voltage source, potential difference. Then the current through this is V or R is equal to I деп чарасың да тема. А мол более молекулярный уровень, да, J is equal to sigma E. Ошол J sigma E-ni Griffith'te, no, I'm sure Prut'ta деле түшүндүрсө керек. Know that such a thing exists. Resistivity, no, here, as I mentioned, J is equal to sigma E, да? Да? Ну, бул жакка тартсам. R is equal rho L over A, аны билсең керек, pipe'тын немеси, да? If you increase area, resistance decreases, which is logical. The bigger the pipe, it's easier for the current to pass. Length uzartsаң, resistivity көбөйөт. Тоже понятно. Resistance, то есть. И resistivity depends on time like this. This is also very important to know. Rho is equal to, it's not for all materials, but for most linear materials, it's like this. 1 plus alpha T minus T0, да? То есть получается, when you increase the temperature, you are basically increasing the resistance. То есть R increases when temperature is increased. Да? And there are some nonlinear cases that are, but in general, for linear materials, it's like this. Ушуну четко билип ал, эстеп ал, анткени эксперименттерде чыгып калышы мүмкүн. I remember we did an experiment where ice'ты салып, потом горячая воданы коюп, типа resistivity өлчөгөнбүз да. Resistivity өлчөбүз дегенде, you basically take a multimeter, да, and then connect to the resistor. Ал жерде бир resistance болот, resistorың болот да. Ошонун resisторун өлчөйсүң. И бул бир сосудтун ичинде болот, ичине ice саласың, hot water саласың, ну температура өзгөртөсүң дагы, ошону өлчөйсүң дагы, потом график чыгасың да. R versus temperature. And you basically get this linear function, which depicts this. This is basically a equation of a line. Y is equal to mx plus b, да? B is equal to rho 0 in this case. Y is equal to rho. X is equal to temperature minus temperature 0, да? So, equation of a line. So, it's good to know. But not all materials follow this rule. We experiment with linear material like this. Another one is non-linear material. And you have to basically plot the functions and find those alpha. This alpha не типа slope-тан таба аласың да. Мондой уравнениең болса да. Rho is a function of t. And also delta rho divided by delta t is basically your alpha да. Slope. Equation of a line in the chat. No, linearization жакшы эле берсең керек, equation of a line. Yeah. Ошол, короче, that's generalized Ohm's law. No, жана айткан. Так. И non-linear материалдар бар. Но, мисалы, диод, да, второй. Синий экен. A plot when the device is semiconducting junction diode. Диодтун voltage IV characteristic болот, да. It's non-linear. All linear. Linear материалдар булар нелер? Обычный резисторлар, да. То есть диод это non-linear девайс, да, нелинейный IV характеристика бар. Вольтамперная характеристикасы нелинейный, да. И you have to know that. Ал туралы задачалар болуш керек. М, Но мол уже более олимпиадные темалар, да, drifting velocity, electric field dependent on this, resistivity. No, resistivity is basically 1 over conductivity, да, rho is equal to 1 over sigma, or sigma is equal to 1 over rho, да, same thing. Sigma is equal to 1 over rho. Обычно материалдарға, semikondukторлардан не, charge carrier'ler, ну, semiconductor, if a material, charge carriers are electrons and holes, да. Holes is basically absence of electrons, да. И conductivity depends on electrons mass, its charge, its concentration and scattering time. Scattering time дегенде, типа, материалда латис болады да, латис деген мондай бір периодическая система. И электрондар for semiconductors, when you heat it up or when you put electric field, you basically support energy to free the electrons. И free электрондар уже жүріп баштайды да, мынтипче. Жүргөндө булар не болот? From time to time they will scatter. Мынтип ойнойт да, мынтипче. Немелерден атомдарға scatter болот. Даже керде электрондун өзүндө. Ошол scattering time is tau, да. Обычно scattering time деп коет. Потом mean free pass деген бар. Mean free pass is the бул scattering time is tau, да. It dependent on mean free pass, which is L. L is basically the distance that electron or any material traverses before it scatters. Scatter деген түшүнсөң керек, да? Collide, collision, да. Ошол. I recommend to read through it and solve some couple of problems, but that's the thing that you may find it very useful. Mean free time of copper is approximately constant. Copper деген бул медь, да. What's the mean free time between the collisions for the conduction electrons in copper? Copper'ın case'inde. И обычно resistor heats up, да. То есть RLC circuit'терде, да, you have RLC circuit'терде, LC is always non-dissipating, да, non-dissipating. Eldana, are you with me?
Да.
How is it going? Like, are the stuff like making sense? Good?
Да.
Хорошо. Азыр эле калды, азыр индукцияга келип токтойбуз, Ана индукциядан кийин башка күн алабыз. L менен C обычно non-dissipating, да? They don't dissipate energy. They just, as I mentioned, C'ни так спринный потенциальный энергиясы деп алсам болот. Q квадрат деленный 2C, да? Мону болсо кинетический энергия деп алсам болот, да? 1 over 2 mv квадрат деп алсам болот. Получается экөө тең they store energy, да? R болсо the dissipating factor. So when you plot the energy, if you put L and C only, if you connect capacitor with an inductor only, like this, inductor көнүлө койсоң, their electrostatic energy oscillates like this. Бул мисалы мол деден баштайлы дейли. Бул мол неме болсо, UC болсо да, кондуктордун чарж болсо, бул максимум болгондо бул минимум болот. Неме үчүнчү? Magnetic energy үчүн. Beskeleton oscillation болот да. It's гармоническое колебание. Бул болсо U magnetic, да, B. Or индукторный энергиясы L деп койсоң болот. Li квадрат деленный 2. Но если сен бул circuitке могул жерге резистор кошуп койсоң, да, if you add resistor, Control C. If you put the resistor here, then instead of this infinite oscillation, you will get what? Decaying oscillation. Да? decaying factor шығады да. Ошол decaying factor именно exponential decay minus gamma some number, gamma t да, over time it's decaying. That gamma depends on R да. And that dissipation is going to heat. То есть резистор, обычно лампочка, либо любой резистор, да, обычно wiredегі резисторлар, бұлар бары heatке dissipate қылады. И how it's happening? Ну, обычно бұл неден happen болады? You have some obstacles and electron carriers, which are electrons or holes, they are colliding with those obstacles. And when they collide, it's heating up. That's why over time, resistor болғанда over time it heats up да, heat болып шығады да. А лампочкаларда напрямую это резистор. То есть лампочка накаливание, да, лампа накаливание, бұлар полностью ошол R менен иштейт. A power dissipated by R is what? P is equal to voltage times I, да? Или work неме алсак да? Energy is dissipated, U десек, is equal to delta V times Q, да? И Q is equal to I times T, да? I times delta T times V, да? И жақшырақ define қылайын, да? Imagine you have wire and you have potential difference is V, да? И your charges flowing is Q. Q is equal to what? I times delta T, да? То есть the work done through this wire is basically I delta T times V, да? И power is equal to du dt, да? Du dt. Получается is equal to VI, да? VI. А V is equal to обычно мне IR, да? IR times I. Получается power dissipated by resistor is usually I квадрат R, да? R. И это V квадрат деленное на R, да? Well. То есть key point here is resistor is a dissipating one. Not capacitor, not inductor or anything else, but the resistor itself. So when you are asked to find the energy dissipated by the device, you usually calculate the energy dissipated by a resistor. Так. That's the thing. So far, so good. And after this, circuits, да, circuit Киркоффның закону, потом junction rules, да, типа conservation of currents, да, in junctions. You should make sure that your currents are conserved. Мол, батарейканы немелер білсең керек. Типа potential drop деген понятиені. Potential drop деген понятиесіне you go across the electric field, да? V high to V low, да? Is electric field. If you go, imagine you have resistor here. The potential drop across this is basically I times delta V, да? No, I times R. I times R is equal to delta V, да? Potential drop. И current and direction кеткенде you are going basic from high to low. So your potential is dropping, да? Current против кеткенде you gain potential basically. It's obvious because current flows from high to low, да? That's the principle that you should always remember. И circuiттері обычно шол мол граф течесін, да? Батарейкада максимальный potential, потом as you go through the resistors, imagining these wires have zero resistance, so there's no potential drop, but in reality they have some resistance, but usually in problems we are asked to ignore them, да? И резистор biraz drop болду, потом еще drop, и it basically it's a cycle, double cycle сияқты. Уравнение. Resistors, how they add up, linearly add up. параллельно оған наоборот азаят да. Параллельно оны inverse қылып не боласың. Now equation comes from equation of equal типа монды болса, you have one resistor, another resistor, another resistor. You are basically saying when they are connected like this, you're basically saying this, these are same potential, these are same potential. So you basically come from there, right? So currents I1 is equal to V деленное на R1, да? I2 is equal to V деленное на R2, and so on. You basically have to observe where the potentials are varying, where are the same. Резисторларда biraz по идее simple-рақ теги конденсаторға қарағанда. I don't think I have to explain much. Besides RC circuit'te ушуну четко билишиң керек. RC circuit derivation, time constant. Whenever you have exponentially decaying stuff, you should know there is a time constant, which means in this case it's I or C, charge in the capacitor or current in the circuit. So your current equation is I as a function of time is equal to I0 e to the minus t over RC, да? Ушундай equationга келгенде, любой бир exponentialга келгенде, minus some alpha t болгондо не болот? They usually ask what will be the value, what will be the time when I goes from I0 to I0 divided by E, да? Обычно бул бир time constant, да? Time constant дегенде t is equal to RC, да? Могул алдында могул фактор, да? RC. То есть RC убакыт өткөндө, exactly RC өткөндө, your current will decrease from I0 to 1 over E, да? Оны изилете алсаң болот. Эмне кыласың? I0 деленное на E дейсиң, is equal to I0 e to the minus t divided by RC, да? You take ln of this. So 1 over E-нин ln алсаң, логарифм ln is equal to mono ln алсаң minus t over RC, да? RC. И ln1 is equal to 0 minus ln E is equal to ln E is equal to ln E is equal to 1 is equal to minus t over RC. Получается, your time is equal to basically RC, да? Потому что вот это уже 1, а вот это ln1 is equal to 0, да? То есть обычно exponential decay обязательно мнение сурашканда. What will be the time that it drops to 1 over E factor дейді, да? Ушундай обычно time constant, да? Тиги RC любой типа алдында prefactor не болсо ошол, да? That will be the time. If you don't know, you just solve it as I showed, like logarithm алып турчу арасында. И mole equation derivation is quite simple. So RC circuit'te четко бил, charged, it gets charged like this, and it gets current decrease like this. Типа экономдың exponential factor бар. И монун derivation по идее biraz узунураак алат. Do I need to show it? Сенде ручка кагазың барбы азыр? Do you have pen and pencil with you?
Да, я все записываю.
Хорошо. Тогда let me show you how do you derive it. So imagine you are connecting this circuit to A, да? A-ге connect кылганда mole equation, да? Киркофтун законун ала турган болсоң, E minus IR minus Q over C, potential drop in both ones is equal to 0, да? И I это вот, I is basically dq over dt, да? In the circuit. dq over dt, Q, R minus Q over C is equal to 0. And we want to find Q as a function of time in the circuit. Да? Получается, без мол интегралды шашымыз керек, да? So it's actually not that difficult. So let's multiply everything by C. So it will be E electromotive, no, батарейканың voltage, да? Times C minus RC dq over dt, да? dt minus Q is equal to 0. When we go to cleaner surface here, where is that cleaner surface? Мына алды clean surface бар екен, ревизия жасайын. Получается, молны шығаршы болсақ, EC minus Q is equal to мол нарқы жаққа өткіз, RC dq over dt, да? Получается, молны бұл жаққа ырғытсаң, и молны бұл жаққа ташта, dt деленный на RC is equal to dq деленный на EC minus Q, да? And you have to solve from 0 to Q. This one from 0 to a time t. We want to solve. Initially, do you remember we have батарейка, we have resistor, we have capacitor, and like this. So initially, there was zero charge, the Q was 0 initially. So we connected like this. Connect қылғанымызда Q0 болчу, то есть получается Q0-дан Q-ға чейін чоғылғаны біз интеграл қылып атабыз. A time also initially it was 0, so from 0 to t, да. И mole integral charge. The mole is easy, да. This is basically t over rc, да. The left side is easy. How about the right side? Right side to башка колормен шығарғалы. Бұл үшін сен mole интегралды шығарыласың. Андай немен, or do you want me to show you how to solve this integral?
Ну, в принципе, можете показать.
Да, потому что mole integral Iowa instructional, да. You have to be able to solve it, and this integral comes up everywhere. Типа, бұны білген Iowa чоң advantage берді саған. И
Вот с ними у меня иногда бывают проблемы, но там вроде я пару раз решала, несколько раз получилось.
Хорошо. То есть, you know the case where you have dx over x интегралын білесің, да? ln x plus c, да? Но здесь mol фактор живет, да? Extra factor. That complicates the things. So in order to eliminate that, EC is basically two constants. E is the initial voltage and C is the capacitor. They are constants. So you have basically some constant prefactor. Аны жоқ қылыш не қыласың? Let's say the bottom one is some constant U дейли, да? U. То есть U is equal to what? EC minus Q, да? А top part, so получается du-ны dq-ға деривативқа ал. If you take derivative of u with respect to q, the first factor will be 0, the second factor will be minus 1, да? dq-ны q-ны дериватив алсаң, dq 1 болады. Получается, your dq is minus du, да? И now, instead of writing let me write, sorry for my writing and stuff. So instead of writing dq деленный на EC minus Q, integrate from 0 to Q, now you replace it with integrate minus du, dq-ны minus q-ды алдық, да? Below EC minus Q-ны не алдық, u-ды алдық. Да? So, and u is equal to EC minus Q, да? То есть, when Q is equal to 0, it's EC, да? EC. То есть U alpha is. И when Q is equal to Q, it's EC minus Q, да? То есть your range also changes, да? Instead of 0 to Q, you are EC minus EC to EC minus Q ға немене қаласың, да? Range қаласың. И the top part, this part is basically ln, да? That's basically ln, да? So this will be basically ln U integrate from EC to EC minus Q. Or another way to write it, ln U just somewhat directly. ln U is basically EC minus Q, да? As you are putting it back. So instead of U, you can write from 0 to Q again back. So получается, you have what? ln EC minus Q деленный на EC, да? And that's equal to T over RC, да, получается, да? T over RC. And you have the exponential factor now. So what do you get from here? So this is basically what? ln EC minus Q. Or you can take like this. This will be, so мындай да, ln a деленный на b мне логарифма, да, ln a минус ln b, да? Білсең керек, но білбесең чутка естеп қал. This is a good identity to know. То есть ln a over b is equal to always ln a minus ln b. Получается ln b over a is equal to minus ln a over b, да? So if we write it reverse, you will get minus the molde. Minus T over RC is equal to ln EC деленный на EC minus Q. You'll understand why I did that, because exponential'да жазғанда мол жазған удобныйрақ болады в конце шығарыш үшін. И what this will lead us to? This will lead us to this. If you take exponential, both sides, exponential e to the power, so e to the power minus T over RC is equal to e to the power of ln EC деленный на EC minus Q, да? И любой момент сенде мол болғанда e to the power of ln A болғанда it's basically A, да? То есть мол часть is equal to EC деленный на EC minus Q, да? Q is at time T, да? Is equal to E minus T over RC. Получается, мы just chose Q as a function of T is equal to what? Step to skip clue, by the way, да? Let's write everything step by step again. Пока что follow қыласың, да?
Да.
Хорошо. В конце мыналдерге жазылтам ответ. Оны бұл жаққа multiply қыл. Получается EC minus Q at time T multiplied by E minus T over RC, да? Is equal to EC. See? Получается Q as a function of T is equal to E C 1 minus E minus T over RC. Так. Это bir жерде минус сайынды жоғалтып алғандай болдым да. Bir жерде минус сайын жоқ болып жатыр. Так. E minus TRC Q. QT. Мгм. Ам, E minus TRC minus QT E minus TRC is equal to RC IEC. Just все. Наверное, все получилось. И C 1 minus короче, как она есть Ильич. E minus E over RC minus EC divided by E minus T over RC is equal to Q as a function of time. Positive factor çıkıp kaldı. Pozitif çıkmış gerek oldu. Where did I get wrong? Все. Понял. Мол, minus ln u olacak gerek var. Шал bir sign minus çıkmalı. Мол, minus ln u olacak gerek. Потому что there is minus sign here, right? Bizim ол жерден bir minus жоғалтып алып тұрмыз. И by default мол minus шығады. Мол by default minus. There is minus factor here. So yeah, now. So there was no need to flip it. Without flipping, we already had minus sign, да? Biz bir ekstra minus sign'ı жоғалтып алып тұрмыз. Түсіндің, поняла? Нет. We lost in the process one minus sign. It was already minus here. So, ну, да, ekstra bir minus var da. Короче, biz bir ekstra minus sign'ı жоғалтып алғанбыз. Получается, ол жерде bir ekstra minus sign бар. Бұл minus болмайды. Түсіндің бе, же ошол жерден minus шығарған жерден до конца шығарып берейін бе? I mean, did you understand where did we get wrong?
Да, я поняла.
Все,
Ну,
все,
я изначально заметила, но я подумала, что, может, так надо.
Не. Но просто bir ekstra minus sign жоғалтып алды ортадан, поэтому биздики plus и t over RC çıkıp kaldı. На самом деле minus мен шығыш керек, да? То есть мы тоже получили, но э, там один minus sign пропустили, да? By mistake из-за этого. Бирок главное бұл жерде сен білішің керек болған нәрсе это то, что когда у тебя есть мондай ситуация бар да, бұл жерде не болды? C E minus Q деген экстра фактор шығып қалды да, dq. Шында кездері сразу substitution аласың да. Bottom will be immediately, любой бір. T деп алсаң да, T is equal to C E minus Q десең, соны деривативқа аласың, dt dq дейсің да. dt dq равняется minus 1, да. Получается, dq-ны minus dt деп алсаң болады деп. So instead of dq over this complex function, you will have what? dt деленный на t келеді да, с минусом. So you will have simple ln, да? Интеграл алғанда minus ln t болады да. T initial, t final. Потом t обратно мол уравнение қоясың да. Там t initial, t final болып тұрды, мынайтып шығарасың да, обратно. И that technique you have to know, it's very useful. Okay, and this is exponential, да, почти любой exponential через ушул арқылы өтеді, да. И мен саған бережу задача беріп қойышым керек, по идее, бұдан кейін. It also uses the same technique. Индукцияда былай көп қолданылады, индукцияда башқа жерлерде да. Ну, везде там где бы ты не видел, где бы ты не будешь видеть задачи с экспоненциалом, там всегда будут такие derivation, да. Шол техниканы жақсы біліп ал, ln a over b is equal to ln a minus ln b, аларында четко. Шол. That's how it is, and as I mentioned, so Q is equal to Q0, 1 minus E minus T over RC, да? RC is equal to time constant also. Получается, мы графигін чейдесің, T is a function of time, it will be exponential өзі мондай болады. А теге Q-ны қойылса, 1 minus exponential болғанша наоборот, да? Inverse of it. And factor will Q0, да? То есть asymptotically it will go to Q0 eventually. At time is equal to infinite, да? It will eventually collapse to Q0, да? Потому что when time is equal to infinite, 1 over E infinite will lead to 0, да? То получается small 0, да? Q is equal to Q0. This is asymptote, да? Хорошо. Ну, мандele bilsen gerek. E minus T over RC is equal to 1 over E T over RC. No? It's good to know. So yeah. And to find current, you just take derivative of charge. Da? The change of charge in the capacitor is basically current in the circuit. Da? So you take the derivative of this and you will get current. Time constant, and so on. And solve a lot of problems with this. You can do a lot of conceptual analysis. That was RC circuit, and next thing is AC currentтерге кейінірек келеді, magnetic fields, да, magnetic field Biot-Savart'ın законы, потом force on the charge, да, force on the charge, magnetic field charge у меня Q V cross P, да, V cross P, то есть получается your magnetic force is perpendicular to both V и B, да? То есть V-ге да, перпендикулярно. То есть cross-продукттың свойствосы, да? When you have a cross-product, the resultant vector will be both perpendicular to both vector 1 and vector 2. Короче, if there is no velocity, there is no magnetic force, да? Right-hand rule, естественно, cross-product обязательно right-hand rule қолданылсын, да? И how to determine the direction, you know that, right? You put your fingers opposite to the second vector, which is B, and rotate to the first vector, your fingers. Fingers will be opposite to vector B, да, like this. Like this. And then you rotate towards vector V, да? Vector V out of the page also, your fingers will be rotated to this side, so your force will be your thumb, да? Right hand rule свойствосы, да? Бірінші vector B ге против саласың, қолыңға. Если vector B is in this direction, your fingers will be in this direction, да? And imagine your force, your charged particle is moving out of the page, no? Out of the page. Then your force is thumbs up, да? If it's into the page, it will be opposite, thumbs down. As you can notice, бұғадағы, тиедағы екеуінің перпендикулярны, да? Magnetic force. Right hand rule'ды біраз разбираться етшің керек. But right hand rule'ны білесің де, қантип шығара алышты векторды, direction.
Да.
Yeah, хорошо. Then that's good. So far, so good. And one more thing is electrostatic fieldтерде не болчу? Positive-тен negative болчу, field. But in magnetic fields, it's from north to south. Да? North and south кетеді, шын четко естіп қал. It's not from south to north, but it's from north to south. It's just a definition, so you have to remember that clearly. То есть, biraz counterintuitive, да? North by the negative түсіндіреді ғой, да? South is positive түсіндіреді. Magnetic field-та наоборот, да? North to south. So that's another distinction. There will be some small types of problems with that related to that. And here, no, radius, да, обычно radius терминен. What is that? Monday, немелер. You have field, magnetic field into the page, and the particle is arriving. So it will be circular like this, and leave it. This radius is R. So magnetic force is basically QVB, да? QVB is equal to circular force mv квадрат деленный на R, да? Геометриясын өзің түсіне аласың, короче, right hand rule-дармен, да? Electrostatic force is in this direction, magnetic force, more direction болуш керек, да? More direction, да? Magnetic force, always. Unit leaves. Sometimes it arrives под углом келгенде, под углом шығады, мондай болып, да? Сол кейстер, да. Но ал туралы задачалар шығарған болушың керек. Знаешь, да, про эти вещи?
Да.
Ну, хорошо. Көп тоқталып айта қояйын. Helical path, да, типа, неме келеді, да? You have both perpendicular velocity and horizontal velocity. Horizontal velocity doesn't feel magnetic force, so it's if there is no any other field, it will be constant. And because of that, you have helical path, да? Like this. Туралы қарашың керек. Motion in two dimensions, yeah. Биосавардың законын жақсылап түсінгенсің ба?
Можете повторить?
Закон Биосавра хорошо знаешь, как?
Думаю, что не очень.
Не очень, хорошо. Биосавардың законы, по идее, it's used to find magnetic field from small current sources, да? Биосавр. И calculating the magnetic field due to current. Сол сияқты, типа. Ну, в конце биосавардын, типа, when you have point charge, your electric field dE is equal to 1 over 4 pi epsilon 0, да? dq, q'нын векторы жоқ, да? Charge. dq деленный на r квадрат, да? И r hat. Если мол болса, да, электростатик филдтерге. Биосавардын законы симулар, да? dB is equal to 1 over mu 0 over 4 pi. I ds, да? ds cross product r hat деленный на r квадрат, да? Бұл закон биосавар. Same thing, да? Если мол барып Гаусс лоға түшсе, да? Гаусс ло. Мол деле барып Амперс лоға түшті, да? Ampere's law не дейді. Ampere's law is mu 0 I enclosed within that space is equal to B times ds. Да? ds это closed loop. Да? Ну. И когда это unit line charge, да, типа вот это current cassette I, magnetic field by right hand rule will be circulating around this. Да? This is magnetic field. Да? This is magnetic field B as a function of R. Получается B times ds, the length across this line integral also circumference. Да? This is R. B times 2 pi R. 2 pi R is equal to mu 0. The current enclosed by this circle is I. Да? Получается B radius R is equal to mu 0 I деленный на 2 pi R. Да? Yeah. But the same equation you can find from this is Ampere's law, да? Gauss law сияқты, да? But the same equation you can find from Biot-Savart, but it will be a little bit trickier. But Biot-Savart, там есть некоторые моменты, когда ты не можешь использовать Ампер, закон Ампера, да? И тогда тебе нужно будет использовать закон Biot-Savart. Хорошо. И an example versek. When can I give you where can I give you the example? Let me give you a very simple example. Yep, here. White space position. No little white space button. Let's say we have like this current passing here, okay? And we want to find magnetic field at point here, P. And your current is passing, this is ds, then. No, I is flowing in this direction, then, I. The radius is radially here. Radius is radially outwards, then. This is r hat. Then. From this point, it's radial outward. ds is in this direction, so angle between them is theta. Then. What Biot-Savart's law says, it's dB dB by this ds current, IDS, is equal to mu 0 миллион на 4π I ds cross product r hat деленный на r квадрат, да? Distance между пунктами. Ну, ds. То есть ds менен current direction берді, поэтому векторды ds-ке қойды. То есть it would be equally same to say that you have vector of I cross R десінде same болмақ. I ds cross R деді. Получается, сен magnetic field'тың direction'ы не екен? ds is in this direction, R is in this direction. So R-ға против саласың, ds-ке бұрай тұрам болып жасам. R-ға против, потом ds-ке бұрайсың. Into the page болып аткен, да? Да. И мон чара алды. How we can solve it? It's equal to mu 0 деленное на π I es times sin theta деленное на r квадрат. Типа r хаттың величинасы 1, да? Ну, короче, буга бир задача чыгарыш керек экен. Without an example problem, I'm struggling to explain what it means. Бирок векторду бир аз түшүндүң болуш керек, да? Кросс продукт понятиясынчы. Азыр бир задача чыгаралы да, ошол жерде ошондой понятно болот. How to use the Biot-Savar's law. Biot-Savar'ın законун буга чейин колдонгонсуңбу? Have you
Да.
used it? Да, хорошо. Ну, если колдонгон болсоң, это понятно. The force between the currents, типа аягында аз Biot-Savar'ы колдонобуз, бирок ага чейин бир force'ты түшүндүрөлү да. When you have two line currents, basically the magnetic field from the first line current will act on the on the current on the second. It's similar to QV cross P. Actually, it comes from there. The mole is by the equivalent to QV cross P. Да? QV cross P. So why is it so? So I is equal to dq dt, да? dt. L cross P. So multiplied by L cross P. I'm also Q dl dt cross P. Mole equality-ны кантип proof кылсаң болот? How you can prove it? Ну, по идее, мол экөөнү proof кылган бир башка бир өзүнчө бир задача негизи. Бирок imagine we proved that case already. So actually they are the same thing. So that means you have a magnetic field from the first wire and it acts on the second wire with the current IB, and you have basically this equation. And it's very simple actually. So wire magnetic field from the first wire is mu 0 IA, да, IA деленное на 2 pi B, да, multiplied by IB, and this is B, B from A. So IL, so you should have L is equal to force, and force per unit length is equal to what? Mu 0 IA IB делим на 2 pi B, Distance между ними. 2 pi D, то есть. Well, famous equation, то есть opposite, same current tegелер attraction болады, opposite repulsion болады, аны right hand rule мен шығарасың болады, magnetic field force, attraction, attraction repulsion, you can use the right hand rule. Is there any, and solenoid четко білу ашың керек, solenoid, toroid дегендерде. Solenoid is basically you have a lot of turns of wires, and then magnetic field is at the center, exactly center is, imagine you have solenoid like this, magnetic field, so let's say it's like this. Magnetic field will be in this direction. This is your magnetic field. And when you have infinitely long, when your L is much bigger than radius, this D or D also, and at the center it's basically you have like this cylindrical structure. Бұл біз надборда осыру юсафодан берген болчу месесен керек. The electric field is basically horizontal. The flux at the center will be basically pi D quadrat is the area. D quadrat is the area times magnetic field. It's magnetic flux. Соленоидты мәнісіне, соленоид шол Ampere'sın law'ын қоя тұрған болсаң, mu 0 I enclosed from one wire is equal to BDS. BDS is what? Magnetic field times H. Where is that? No, magnetic field times H is horizontal. From A to B is H, magnetic field times H. At the top, there is no magnetic field because it's infinitely long. The magnetic field is traversing like this. Like this. Yeah. Is equal to mu 0 n is equal to number of turns divided by total length L. All the n is equal to what? N is in this length is equal to n times h. So mu 0 I enclosed is n h times I is equal to BDS plus B times h. Получается, magnetic field of the solenoid at the center is equal to mu 0 n I, or mu 0 number of turns I divided by total length L, same thing. Solenoid уравнениесін четко естіп қал. It's very important. Solenoidты, toroidты четко білішім керек. Наизусть, mu 0 ni or mu 0 n over Li. Same thing. Аны магнит негізі derivation Ampere's law'дан шығады. Gauss law for magnetic field. Solenoid, current carrying coil as a magnetic dipole. Magnetic dipole деген бар. Mu is equal to IA, Анадағы practice қылышым керек, по идее. Обычно не болады. Обычно you have a coil loop, I belong, its area is what? This area, it's n hat is equal to area PR quadrat, R quadrat. So your mu by definition is I times area, is what? I times I across the loop times area PR quadrat. This is your magnetic dipole moment. I recommend you to go through these pages. Не бар екен бұл жерде. 29.5 та 29-5 менен қарап қоюуну recommend етем. It's very important. Now these are all the equations. Small, misal dipole moment, I remember in a lot of places. Small equation'ların барын чыгарып чыгууну, проблемды барын чыгарып чыгууну recommend etем. Small, same thing that P. This can be solved with Ampere's law as well. 21. So by Ampere's law, this is the radius then. Radius. This is another radius. Radius 1, radius 2. Ampere's law was also. Its magnetic field will be like this then. More radius, radial, more tangential. Out of the page also up. More also out of the page also. Тоже more direction then. Потом have two magnetic field from first top through this from the bottom second, and then they're equal because it's same distance and symmetric. So, and you do that simple geometry problem. Cos sin there. Its x-axis will be cancelled. Y-axis will add up. So you will add up and then calculate for the vertical axis. This type of problem is basically Ampere's law. No, for circular thing, you have wire and at radius r, it's mu 0 I делен на 2pr dedik then, magnetic field, B at r. Here you have all at this distance then, получается B r is equal to mu 0 I over 2πr then, 2pr. И бұл circumference across the circumference болғанда how do you... Короче, мұның ответі не болады? Мен ответін четко істеймін. Mu 0 I over 2r да? I over 2r. Писи жоқ. Но how to get rid of pi? Короче, no, it's very instrumental to understand. No Google. You can come from Ampere's law as well, or Biot-Savart закон Менделеевским вот, equating. How? Because let's solve with Biot-Savart законымен шығаралды, мол уравнениені. Типа magnetic field at the center де табышымыз керек when you have a circle. So let's take as infinitesimally small ds, да? Yes. Radial here, r hat, mu 0, делен на 4p, I, es, cross r hat, делен на r квадрат, you integrate. So ds integral алғаныңда, it should be integrated as 2pr, да? 0 to 2pr, да? ds cross product r is basically they are perpendicular. So sine 90 is 1, да? Получается, you have mu 0 делен на 4p, I, ds will give you 2pr, да? It's constant. Sin 90, sin p over 2, which is 1, делен на pr r квадрат, да? Получается, 2p менен могу 4p кетет, 2 калат. Получается, mu 0 I деленный на 2r, да? Или b at the center. This is from Biot-Savar'ın законунан да. Ampere's law'нун законунан болсо кандай кылып чыгарасың? Ampere's law'нун законунан mu 0 I enclosed or I in is equal to b times ds болчу. B times circle also at the center. Mu 0 I enclosed. B times 2 pi r десек. Мындай бир circle болот да. Да, турамыз болот. Амперс лоудан по идее чыкпай атат. Биосавардан оңой эле чыкты да. Амперс лоуду чыгаргандан кийин өзүмө homework болсун. Потом посмотрим. Ну, короче, да. Амперс лоу менен пока логикасын түшүнгөн жокмун, чыгарса болот. Ну, короче, в конце могуну чыгардык да. Эгер могу логиканы кайра чыгарчу болсок, for any angle arbitrary theta angle болсо, тогда не болот? Mu 0 by Biot-Savar'ын закону менен 4p, да. I, yes, cross product, r hat, integrate, divided by r квадрат, да. From 0 to any angle theta болсо ds не болот. Могул арканын length'и не, типа your infinitesimal length here is ds, да. ds is equal to арканыкы не r d theta, да. Когда у тебя есть радиус, angle theta болгондо, могул length не, d theta болгондо, length is equal to r d theta, да. Is equal to ds. Понятно, да?
Да.
Да. Но кросс-продакттын не болуп жок болуп кеткенин түшүнүп атасың, кросс-продакт, потому что r hat менен ds экөө перпендикулярный болуп атат да. Из-за этого кросс-продакт автоматически 1 болуп калат. Жок болуп кетет. Почему r квадрат в интеграл не входит? Потому что у нас ds независим от r, да? Но r независимо болгончо сыртка чыгып берип атат да, поэтому мы не используем. А ds это r d theta, да? R d theta. Получается от нули до theta is the general equation, да? Получается у тебя general equation екен mu 0 I делен на 4p r квадрат. 4p r квадрат. 4p r квадрат. Жогоруда болсо r theta, да? R менен бар кетсе. То есть general equation екен b of any угол, мынау угулу, да? Угулу. Any угол theta is equal to mu 0 I theta делен на 4p r кен, да? И когда угол равняется 2p, да? 2p, это будет circle, да? Полный circle. Полный circle болгондо b will be mu 0 over 2r, да? Mu 0 I делен на 2r. Могу general version, да? Биосавардын законунан келип чыкты, да? жазылған біраз уақыт берейін. Понятно, да?
Да.
Хорошо. Если понятно, тогда хорошо. То есть обычно шел под углом келгендер ушул угол менен. Мен ойымча олимпиадада мындай задачалар келип калат кейде келгенде. Ошол general биосабардын закону general equation чыгарасың да, анан уголга любой уголду коесуң да. Пай over 2, пай. Если 90 градусов, тогда пай over 2. Если полный circle болсо 2 пай. And so on. Так. Ал менен magnetic fieldтерди полностью бүтүрдүк да. Ну, two coils. Another problem. Would recommend to solve this. Two coil'ларды. Ну, короче, задачаларды ачып полностью сага түшүнүксүз болгон задачалар баарын алып чыгарганды рекомендовать этем. I really recommend to do those. And they have solutions, and whenever you don't know the solution and so on, I recommend you to ask. Finally, we are at induction, and this is the best chapter I like from Resnick. It explains everything so neatly. Главный закон Фарадея, да? Changing magnetic flux generates EMF, electromotive force, да? Ошол. And if the loop is replaced by closed loop at N coil turns, then it's N dF dt, да? То есть instead of one flux, you have N flux, да? Magnetic flux, ну, Gauss law окшош эле, magnetic field times delta A, да, dot product, and so on. Бул эксперименттен келип чыккан, Faraday эксперимент кылган, да? There is a coil and he put magnetic source and then changed its flux, and then there was change in the current, so without any battery, so which means there was induced electromotive force, which is induced battery generated because of this. And the principle is what? The principle is nature, природа opposes the change, да? Change oppose кылат, да? Типа direction'ды ошол жерден таап аласың да. In which direction деген вопроско. It tries to preserve its initial state. Initial state не болсо ошону preserve кылгысы келет, да? Ну, бир задача чыгарабы ошол, аябай понятный болот. What is the problem? Now imagine this problem. There is no any battery, but there is still current induced. Why? Because we are changing magnetic flux. And how you know the direction of the current? You know the direction of the current from the way that you are pulling it. You are pulling it away. So initially, flux initially it was B times small L times some B дейли. Ну, B дегенде. Ну, допустим, B деп коя берели. B. This is initial flux, да? A final flux не болот? B is getting smaller and smaller, да? Your magnetic field is constant, but your area is shrinking. So in order to compensate that, you should induce, there will be induced current to increase the magnetic field in this field so that the flux will be constant. So the principle of what? Principle fiindi preserve кылыш керек, да? There are two ways. One, to keep A constant, area constant, which we cannot do it, да? Потому что биз drive кылып атабыз, area constant кармай албайбыз, да? Получается, the second case is magnetic field өзгөртүшүбүз керек, да? We should ramp up the magnetic field so that with smaller area, we still get the same flux, да? To do that, we should basically increase the magnetic field, which the direction is айдын direction mondo болот, induced I. Why? Because magnetic field generated will be outside from this, inside to this, да? Same. inside in this case, outside in this case. Same in this direction as well, inside. Получается, biz extra magnetic field inside generate qilib da, because of that. So, induced EMF is equal to minus d phi b dt, да? E dt. Minus d flux B не. Flux B это B times area, да? B times L times B, да? Divided by dt, да? What is this? This is basically B is constant, L is constant, B is changing. dB dt is what? No, dB dt is basically B is x, да? dx dt is what? dx dt is velocity, да? То есть induced EMF is basically PLV, да? С минусом. Минусом, да? И when your current, when your loop has some resistance R болғанда, this is basically IR, да? IR is equal to minus PLV, да? Получается, the current induced, I induced, is BLV деленный на R ekan, да? Resistance R. This is the key thing that you have to know. So, what you have to know is nature tries to keep it the initial state, да? Initial state не болса, ошону кармаган аракет кылат. И аны кармаштыр аракет кылыш үчүн induced EMF, да, обычно. Induced EMF is induced in such a way that it wants to preserve its initial state. And from there you define, you find direction of the magnetic field. I mean, current, induced current. And that induced current, now you have another second step. Second step is what? Now you have current. You have magnetic field, and you know that force from the current carrying loop is what? I, L cross B, да? Получается, mole, it will feel the force here, it will feel the force here, it will feel the force here. But the thing is, this current and this current, they are opposite, same lengths, so they will cancel out. Huh? Получается, the only force that will be left will be from this side, which is I induced, length is L, да? Большой L, и B. Notice that we are not taking into account the induced magnetic field, because it will be illogical to put типа magnetic field өзі түзген magnetic field өзүнө force кылып иштете албайсың да. Типа когда у тебя есть only charge, there is no force, да? Force electric is equal to zero. Почему? Потому что electric field created by itself will not act on this charge. Да? When we talk about the force, we talk about the electric field that's generated by some other charges. So let's say we have gigantic minus charge. So if there is electric field because of this negative charge, then it will be force is equal to, here it will be Q times electric field from the minus charge. Да? То же самое ошол нерсе, бул жерге бул принципке иштейт. То есть when you talk about the magnetic force, you talk about magnetic force that's from outside, not from the induced itself. So from outside, there's intrinsic magnetic field that's across this shaded area. And you have current that's induced, I. So the force will be between I and the intrinsic magnetic field that's from the outside. But we ignore the current magnetic field generated by induced I. Does that make sense?
Да.
Хорошо. Good. Yeah, this is the thing that you have to know for the induction, and the rest is very easy. Мына жерде типа немен сурапты да, канча heat induced болот, same thing as I said, I quadrat R, I induced is BLV деленный R, and so on. You can reformulate Ampere's law Faraday's law diyeyim. EGS de olsun bu instead of electromotive force, which is similar thing. Yeah, we will talk about this more in detail when we study Griffith. Индукцияны self-induction деген понятие бар. Это уже катушкаларға келдік. Катушка biraz tricky, да? Катушка үшін biraz advanced biraz неме керек, да? Понятие. An induced EMF appears in any coil in which the current is changing. Типа катушка үшін мен biraz өзімше даярданышым керек. Катушка мындай немерақта. It's very easy to confuse people if you don't formulate it correctly. Катушка бар, mutual inductance бар, inductance energy бар, да? Но обычно electrostatic energy, magnetic energy, алар қайерде store болады? They are stored in fields, да? That's the critical thing. And also, one last thing that I have to explain is magnetic force, да? Magnetic force, да? Ана magnetic fields, мына жерде QV cross P бар ғой? Типа принцип бар, magnetic force do no work деген. Magnetic force do no work. Why? Because FP is perpendicular to velocity, да? Получается, work, delta work is equal to force times dl, да? Is equal to force times v dt, да? And dot product. But we know that velocity and force, they are perpendicular, it's zero. То есть magnetic field, анда-мындай дилемма, да? Типа дилемма не дейді. You have magnetic field region, да? Your particle is approaching and then it's coming out like this. Then where is the work done by magnetic field? I mean, obviously it's changing its direction. Magnetic field just changes the direction of the particle, but it doesn't do any work, да? Шол кей нәрсе бұл афода келген. Я еще дважды смотрел, да? Екі рет қатыштым, афо екеуінде де күшін задача келген. То есть it's very important to remember. То есть magnetic fields, да? FP, they don't do work, да? Типа all work is equal to zero, да? Он четко билал, истопал. Because all what they do is they redirect the velocity. Типа velocity stays constant, it just redirects to different direction. And that's it. That's very important to remember. No, индукцияға келіп тоқтадық, да? Ертең индукцияны қараймыз. Бірақ бір задача шығаралы. And шолмен тоқтатып алды. It will be very interesting to solve problems. What kind of problem we can solve? 18-ді шығарсақ болады, либо 27-ді шығарсақ болады. 27-де instead of area, the magnetic field is changing. See? Magnetic field is some constant of E квадрат дейді. Y-ға жарыш өзгеріп тұр, да? Либо мол 28 шығарсаң болады. Тағы даже homework беріп қойсам болды да екен. I can give you a homework problem. 27 and 28. Let's solve 28 and then 27 will be homework for you. Okay. 28 қандай шығарамыз? A rectangular loop of wire with lengths A and B, length and width, and resistance R is placed near an infinitely long wire carrying current I дейді. Ну, wire I-дан magnetic field қандай өзгереді? At radius R, we know from Biot-Savart's second or Ampere's law, what? Mu 0 I деленный на 2πr, да? То есть on the wire at radius R, its magnetic field will be at radius R, will be this, да? Мы делюсь. Получается, the farther it goes, the weaker the magnetic field is, да? when your this box is moving away from the wire, obviously magnetic field is decreasing that because it's decreasing with respect to radius. But it should compensate. So magnetic field I'dan qaysi direction'da шығар? In this direction it will be out of page by right hand rule. By your thumb is here and your fingers are rotated like this Yes. Your thumb is current I. Magnetic field is out of the page. In this case, it's into the page. So you should produce more into the page magnetic field to preserve your initial state. And which current direction, induced current direction, will produce that? It will be this current direction then. Okay. This current direction. Come on. Magnetic field by this induced field will be out of the page in this case and into the page. Into the page. Okay, so now we know that. We have to know the rate. Rate тауыш үшін biz dφ тауышымыз керек. То есть in order to find current, when the center of the loop is at distance r, what are the magnitudes of magnetic flux through the loop? R distance away, the flux қанша дейді? That's quite simple. Flux phi is equal to B times area. B is mu0 I deленное на 2πr. Area also. Across this dashed line, your magnetic field is same. Получается, the area should be what? This dashed line times the thickness, no thickness, dr. Получается, A times dr. This is the area. You should define like that. And you integrate from r minus b over 2 to r plus b over 2. Дистанцияны чоңғарды ойлансақ. dr. Понятно. dr, ln мен жатқан. Получается, біздің ответ не болады? mu0 I деленное на 2p жоғарыда a бар. ln r 1.5p екен r-ның валюсы. То есть this is b болады екен. Бұл 1.5 plus 1.5p is 2b, Получается mu0 I деленное на 2p жоғарыда a бар. ln 2p деленное на b. B'лер cancel болса ln 2 екен, That's the flux for the case A, in solution show. The current induced in the loop. Current induced in the loop is what? dFP dt minus is equal to electromotive force or voltage is equal to IR, I induced times resistor, Получается, мол интервал аласыз, dpb dt эмнеге барар болот? d dt mu 0 I over 2 pi over the a bar. A is constant, A is not changing. Velocity somehow relate кылышыбыз керек. ln2 is the flux is equal to I induced times R. How do you find the velocity? In this case, everything seems constant. Mm, mm, так. I think we should go back a little bit and solve when R is not cancelled yet. No? D dt integral, let's see, minus R minus P деленное на 2, R plus P деленное на 2, mu 0 I деленное на 2PR, ADR is equal to I induced R кенде. Так. What is the current induced in the loop? We have to find the phi dt, and we know that area is constant, A is constant, B is not constant. So we have to find dB dt. dB dt is what? dB dt is basically mu 0 I деленное на 2PR dt кенде. Now логиканы түшүндүм да. I mean, forget about the top part. Sorry for that confusion. I think I found the algorithm to solve it. So we know that area is staying constant. Бұл loop қаяққа барса да area same да, no? Area is staying same. But magnetic field inside is changing да? Magnetic field inside is getting smaller and smaller. So we have to find dB dt instead of this overall. Area қачып кетеді, dB dt қалады да. Получается, d dt mu 0 is constant, it goes out. Mu 0 I is constant, goes out. 2p is constant, goes out. d dt 1 over r кенде. Муну тапшырыш керек. Is equal to 1 over r dt интеграл калсаң не болот? Дериватив калсаң. R minus 1 d dt болсо minus 1 r квадрат dr dt. Пока понятно, да? Мен жазаткандарым.
Да.
Хорошо. Окей, ну. Короче, dr минус 1-ді dt-ге алдық. Шында 1 over r квадрат с минусом. dr dt. dr dt это velocity, да? То есть радиустың өзгергені бұл it's just velocity, да? Получается минус velocity делено на r квадрат екен, да? This is dr минус 1. То есть получается бізде мол dB dt is none other than minus mu 0 I деленный на 2p v деленный на r квадрат екен, да? И so now fluxты тапсаң, change of flux dphi dt is equal to area dv dt, да? Is equal to да. This times dA. Like, times dA интеграл власына. It's a dr multiplied by mu 0 I деленный на 2p r квадрат toward velocity integral. Instead of ln, you get something else. You get 1 over r. Let's check the solution. Let's check the solution. 28, chapter 30, chapter 30, problem 28. Chapter 30, problem 28. 51 bit. 37. Where's 28? 27, 28. Биринчисин туура таап турбуз, да? L'н чыккан бизде дагы. Потом B'да тоже туура таап турбуз. B over r квадрат, I loop is equal to d dt. Мына бул сразу ln'ди деривативге алыптыр. Арын чыгарбай туруп алыптыр да. Арын чыгарбай туруп. Бирок в конце would we find the same thing? Would we find the same thing? dr кылсаң, dr, what would be the value? Короче, бизде понятно, туура, ln. B'ны просто ошону деривативге алыш керек болчу, да? Ошону деривативге алыш керек болчу. Да, биз ушул жерден ката кетириптирбиз. Бирок логикасын түшүндүң, эмне кылыш керек экен? Did you understand the logic behind it?
Да.
Да. То есть биз бир аз overthinking кылып салыптырбыз. Ну, я думаю, биздики менен деле туура чыкса керек эле ответ. ADR, если многону интегралга алсаң, 0-дон, но R минус B деленный 2-дан, R плюс B деленный 2-дан, 1 over, bizde factor 1 over R чыгат да. Элэнди дериватив алгандан бир аз чочуп качып кетиптирмин да. Так. Да. If you understood, it's good. Бирок аябай жакшы задачалар бар Resnick'те. I really recommend you to solve those problems and you will learn them. And As you can see, the solutions are really neat. Like it's very well explained. Так. М, мгм. Потом ушул нерселерди чыгара алса, ижолордо по идее same уровень келет. Бифолордо деле почти same уровень. If you can solve these types of problems for induction, it means you are basically you are ready for usual level problems if it comes to induction. Индукциялар келсе уже точно чыгара аласың да. That's the beauty of it. So I really recommend to open this chapter and solve these problems. For instance, 33 looks also very interesting. Yeah. Another current parak and magnetic field because of the current. A similar type of problem, slightly different than what we saw before. Null bar, да? Какой-то границадан кейін flux азайып баратат. mg. No, this is very similar to visual level problem. Instead of force or something else, its gravity is pulling, да? И induced current қандай болады, потом force қандай, да? Шулар полный чарасы. Какой-то моментте magnetic field менен бұл induced current менен force oppose болуш керек. То есть even in terms of force, it looks very intuitive. Типа бұл түшүп баратса, even in terms of force, it's very intuitive. Happened. So I somehow lost the screen. Back. Let me share the screen. No. Even in terms of the force, it's very intuitive. Why am I saying that? Because, as I said, nature tries to preserve its initial state. Да? Природа пытается сохранять свой первобытное состояние. И бұл не болады. То есть mg бұны тартып жатса, значит, force бұл жаққа обратно тартыш керек та. Let's examine that. So your flux is decreasing. So induced current should be induced in such a way that it should produce more magnetic field in this direction. Да? Мол direction'да magnetic field чыгыш керек тура келет да, чтобы preserve. Получается, electric current should be in this direction, да, induced current. Болуш керек. Magnetic field карайлы. You have force magnetic field is equal to IL cross B, да? То есть I менен B ге cross product. By right hand rule, B ге против саласың қолыңды, out of the page. I ға бұрасаң, your magnetic force is in this direction, да? And that's very logical. So your gravity is pulling away and magnetic force is opposing that. Similar. At some point, you have a new type of problem. mg minus force P is equal to ma. Да? Actually, this is AFO problem. AFO душной задача чыккан. Точно identical, то есть мол уровне same. AFO душной задача көргөн. Даже very close to recent years. Задачалар чыгарып чыкты экен. That's a really good starting point for you to solve. Да? Потом mu cross b-ни четко үйрөн, да? Where is that? Индукциядан мурун болуш керек ал. Torque is equal to mu cross b деген. That's it. Magnetic fields. Torque and current loop analog. Бирок түшүнүп алсаң өзүңө эле жакшы. Torque is equal to mu cross p, да? Potential energy mu dot p. Ушул тууралуу задача чыгышына туура келет. Review and summary 28 экен, 28, 29 and so on. should solve problems. Where are those torque type problems? Torque and current loop içindeki. 51. Sounds really interesting problem. 52 тоже. Магнетический диполь момент. Там mutual inductance вообще көрмедім, ал походу inductance'дан кейін шықса керек. Да, mutual induction'ды кейін өтеміз. Second session electromagnetic waves, Maxwell's уравнение, mutual induction, inductance, шолар туралы болады. Нашел. Эльдана? That's it. Any questions from today?
Нет, все, спасибо большое, все было понятно.
No. Did you learn like new stuff? How was your impression? Should I go faster than this or
Да,
same thing?
да нет, нормально.
Нормально. Хорошо. Ну, сен главное үйреніп отқан болсаң, көп жасай. Ошол эле главное, да? Потому что үйрөнгөн сайын уровень өсө берет. Ну, мен айткан индукцияларды чыгара алсаң, Resnick'теги задачаларды чыгара алсаң, я гарантирую тиги ижодогу задачаларды точно чыгарасын. 100% чыгарасын. I mean, it's that simple, да? Просто ал индукцияларды впервые, когда ты будешь читать, ну, когда ты читаешь, тогда будет сложно, да, понять. Но когда кто-то объясняет так, по идее, вообще simple, да? Вообще простые вещи. И ижодо, по идее, простой эле нерселерди берет да, немени индукциялар тууралуу. Индукцияда буга чейин берген задачалар вообще кыйын жерин көргөн жокмун да. Все решимо. Ошол. Но негизи ижодо оор задача бербейт, бирок especially индукция is piece of cake. Ошол. Ладно тогда. И part 2-ну дагы бир аз ойлонуп дагы айтам го. Бош убактым болгондо.
Хорошо.
Homework is solve those problems. Индукциялар тууралуу бир аз задачалар чыгарчак.
Мгм.
Торг, морг. 28, чаптер 28, 29 и 30, да? Ошолор
Мгм.
тууралуу. И потом кайра прутка кайтып прутту өтөрөсүң. Solution бар, Resnick китеп и книжка, и solution у тебя есть, наверное, или нет?
Есть.
Да, хорошо. Ладно тогда. Окей, удачи. Здорово,
Спасибо.
Мгм. Да.
Мгм. До свидания.
Мгм.